My name is Tim Gutowski. I'm a student at Columbia in the MBA XMS program. Before Columbia, I worked at CS, and they're a consultant firm focused primarily on pharmaceutical companies. I worked heavily with the analytics teams at these companies, so I have a very deep understanding of the problems that they faced and exactly how they go about solving those problems. The biggest issue that these analytics teams faced was data mastering. And by that, I mean taking data from different data sources, finding the conflicts between them, and then narrowing down into a single source of truth. The best way to explain this is with doctor location. So imagine you have three data sources, two of which say a doctor is located in the Upper West Side of Manhattan, and a third which says the doctor is located in Stamford, Connecticut. It makes a big difference where you send your sales rep, depending on which data source is true. The way that these pharma teams solve it today is through Excel and through Google Maps, which is obviously slow, it's inefficient, and a lot of times it's just completely wrong. And this issue happens across all different types of data sources and data types, and not just this one specific instance of doctor location. To solve this, I'm building Kernel. Kernel is a team of AI agents that acts as the operating system for data. It continuously scans all data sources, finds conflicts, and then fixes them proactively. Pharma teams often have different cloud platforms storing their data, so Kernel will plug into each one, understand how the data works, and then bring everything together into one consistent view. So I know this problem from firsthand experience, but of course, I wanted to speak with other people in pharma to understand it a little bit more deeply. I spoke with senior managers, directors, VPs across Pfizer, Sanofi, BMS, etc. They all confirmed that this is a problem and it's getting worse. And it's getting worse because of the amount of data that's available. With more and more data, it's becoming more and more fragmented across different data systems. They also told me about two key points, one of which moving data is long, it's hard, and tedious, and no pharma company wants to move their data from one data system like AWS to another data system. It impacts the entire company and not just analytics. Second is that data privacy is very important. So a data vendor like IQVIA, for example, won't want their data shared with another data vendor like Komodo Health. To solve each of these problems, I spoke with Columbia professors, students, and former ZS colleagues to understand how they could be addressed. To solve the issue of moving data, Kernel will have to be containerized. And what that means is that the code for Kernel will have to run in one environment, like AWS, the exact same that it'll run in another environment like Snowflake. To solve the issue of data sharing, the AI agents for Kernel will have to make use of federated learning. And all this means is that the learning process for these AI agents takes place on a third-party system, and so that no data from a third party is shared with another third party. So I'm applying to build that to take these learnings and build a functional prototype. For the spring term, I have a clear technical roadmap, and I'm looking for three specific engineering students. I'm looking for a backend engineer who will build the containerized Python application, and this will run inside different cloud platforms like AWS and like Snowflake. I'm also looking for a machine learning engineer. They will implement the matching algorithms that'll run Kernel in the backend. And I'm also looking for a full stack engineer to build the UI UX components of the platform. My goal is to have Kernel running on synthetic data by midterm in the spring. And by the end of the term, I want to have identified three pharma teams who are interested in running a pilot of the beta version. So I have firsthand knowledge of the issue from my time at ZS. I validated the problem and the solution with pharma leaders and Columbia professors, and I have a clear roadmap on how to build this prototype. So I hope that you'll consider my application for the Build Lab, and thank you for your time.